You see the headlines every day, right? A new AI model just shattered another record. It's smarter, faster, better. But how do we actually know that? The answer comes down to something called a benchmark. It's basically the official report card for AI. But what if that report card is fundamentally flawed?
I mean, it seems like a simple question. How do we really know if one AI is better, or maybe more importantly, safer than another one? This is one of the most fundamental challenges in AI today, and believe me, the answer is way more complicated than you might think.
We've all seen leaderboards that look something like this. You know, a nice, clean ranking that seems to declare a clear winner. But what if that ranking is just an illusion? These scores are driving billions of dollars in investment, but they're often built on a testing system that has some deep, hidden problems. So let's get on the same page. What is a benchmark exactly? The easiest way to think about it is like a standardized test for AI, kind of like the SATs. It uses a specific set of questions, the test data set, and a scoring system to spit out a final grade. In theory, this is great. It gives us a consistent way to measure and compare different models. So here's our game plan for this explainer. We're going to start with the AI scoreboard and the race to the top. Then we'll expose the cracks in that system. We'll see how it's being actively gamed, look at the quest to design a better test, and finally, really dig into why all of this matters so much. All right, first up, the AI scoreboard. You have to understand the race to get to the top of these leaderboards has become the defining obsession in the world of AI. It shapes pretty much the entire direction of research and development. Okay, this right here illustrates the absolute core tension of this whole problem. On one side, you've got the capabilities frontier. This is all the amazing stuff an AI can do, even if it only does it once in a blue moon. This is what gets the headlines. But on the other side, you have the reliability frontier, what an AI can do perfectly every single time without fail. And here's the issue. The gap between what an AI can do and what it does reliably is getting dangerously wide. So you have to wonder, why is that gap so huge? Well, it's because the testing system itself is broken. There are fundamental cracks in the foundation, which means those high scores we see on the leaderboards can often be a complete mirage. Researchers have pretty much zeroed in on three critical flaws. First, you've got data contamination. This is basically just cheating. The AI has already seen the test questions while it was being trained. Second is benchmark saturation. This happens when the test becomes too easy, so all the top models get an A+, which hides their real weaknesses. And third, there's construct validity failure, which is a fancy way of saying the test isn't even measuring the skill it's supposed to be measuring. This quote just hits the nail on the head when it comes to construct validity failure. Think about it. An AI might ace the bar exam, but that doesn't mean it's a good lawyer. It just means it got really, really good at passing that one specific test. This encourages shortcut learning, where the AI finds a clever trick to pass the test that's completely useless in the real world. And this leads to something genuinely dangerous called safety washing. This is what happens when a benchmark that's supposed to test for safety is actually just testing for general intelligence. So as the models get smarter, their safety scores go up automatically. It creates this false sense of security that the model is safer, when in reality, its underlying risks haven't been fixed at all. So, okay, the tests themselves have these huge fundamental flaws, but it gets worse. These flaws don't just exist by accident. They can be actively exploited. This is where we get into the whole idea of gaming the system. The key idea here is something called Goodhart's law. It's a classic principle that says the moment a measure, like a benchmark score, becomes the all-important target that everyone is chasing, it stops being a good measure. The intense pressure to hit that score corrupts the test itself. And data contamination is probably the biggest and most obvious example of this. It violates the number one most fundamental rule of testing anything. You don't give the student the answers before the exam. But in our world of massive web-scale data, that's exactly what's happening, sometimes not even on purpose. So how does this contamination actually work? Well, it's a shockingly simple, almost unavoidable three-step process. First, researchers publish the benchmark questions online, usually on a site like GitHub, so everyone can use them. Step 2, giant web scrapers just hoover up the entire internet to create training data for the next big model. And boom, Step 3, the model is now contaminated. It's not learning how to reason anymore, it's just memorizing the answers. But here's a twist. It's not always about getting the highest score. Sometimes, developers do the exact opposite in a practice they call sandbagging.
They might intentionally program their model to do worse on a safety test, maybe to try and avoid triggering regulations. So the scores, as it turns out, can be manipulated in both directions.
All right, so it sounds pretty bleak, doesn't it? The tests are broken, they're being gamed. So what's the solution? Well, the good news is that researchers are in a constant arms race to design better, more robust tests, ones that are much, much harder to cheat.
We can actually see this evolution playing out in real time with benchmarks for multimodal AI. That's AI that can understand both images and text. The first generation, called MMU, was a good start, but it was flawed. So they released a second generation, MMU Pro, which was hardened to fix those flaws. And the latest version, MM Star, was built from the ground up to be nearly cheat-proof.
So let's look at exactly how they fixed that original test with MMU Pro. They did 3 really clever things. First, they filtered out any questions that a text-only model could solve without even looking at the image. Second, they bumped up the multiple choice options from 4 to 10 to make it way harder to just guess the right answer. And third, this is the brilliant part, they embedded the question directly into the image itself, forcing the AI to actually see and read at the exact same time. And here is the proof that it worked. On the original Flawed MMU test, a model like GPT-4o gets a pretty respectable 69%. But on the new, hardened MMU Pro test, its score absolutely plummets to just under 52%. That massive drop proves the original score was inflated. The new test is harder, for sure, but it's also a much more honest measure of what the AI can actually do. Okay, so we've been deep in the technical weeds here. Why should you care about all of this? Because these benchmark scores are escaping the lab and having a massive impact on the real world. They are shaping everything from the products we use to the laws that govern us. Look, these scores are not just for bragging rights. They literally guide the entire direction of AI research. They influence where billions of investment dollars are going. They're being written into incredibly high-stakes regulations like the EU AI Act. And maybe most importantly, they shape how all of us perceive AI, how much progress it's making, and whether it's safe. If our measuring stick is broken, all of these things are at risk. Which brings us right back to that central problem, that gap between the capabilities frontier and the reliability frontier. The difference between what a model can do in a perfect, sterile test environment and what it does consistently and safely out here in the real world, that gap is still dangerously large, and our flawed benchmarks are hiding just how big that gap really is. And so I'll leave you with this one final question to think about. We're pouring unbelievable amounts of money, time, and talent into optimizing our AI models to get higher and higher scores. But if the tests themselves are flawed, what are we really building? Are we optimizing for genuine intelligence and true reliability, or are we just getting better and better at passing a broken exam?